Okay now, guys, welcome back. Now we are getting so close for the end of this module. On the previous session that we had, we noticed that when we just worked with a model, essentially with the memory, because we created a generated quantities for our stand model. You saw that we just called that the generated quantities for stand, and that's why we just call that the model with the memory, because it's going to remember the replicated data which the stand is going to generate. And then we noticed that we had some problems for the convergence for some parameters. And now before we finish that tutorial, I said that you can just change with some of the parameters, like the step size, and also the number of the iterations, increase the number of the iterations, and decrease the step size that you have in your algorithm to make sure that the model is going to converge. And that's the thing which I did before I just come for this tutorial. I changed the number of the iterations from 7,000 to 9,000 iterations, and also I changed the step size and reduced that by adding one more zero before 1. I ran that model, and you see that, for example, the trace plots which I got, it shows that the full convergence for all the parameters, and at the same time, when you just do, you print, the model, you can see the R hat statistics, which is all of them, is going to be around the same thing that we have. Except for this one, which we can just increase the number of the iterations to something higher, then also, but essentially for the alpha, beta, and gamma, and sigma almost we have the convergence, but you could have had a better convergence if you had, for example, the number of the iterations from 9,000, for example, to 10,000 or something more. But I should say at this stage, we are okay with the things which this is right now there, and now we just want to move on to check, the replicating power of the model that we created. Okay, but before that, I'm just gonna, create some kind of a yrep, which we had. You remember, I'm just gonna use the same name which I created at, the R stand, y underscore rep. I'm gonna create the same thing there, and I'm just gonna put that as, as a matrix, because we are just gonna need it as a matrix before we just move on. And I just put, as an object, I put the quadratic model, which is going to be a replicated one. And more importantly, the thing which is going to be very unique here, if I'm just going to choose only, the parse, which is going to be essentially the y rep. Why do we do that? Because if you remember that, if I, for example, if I, execute that line by pressing Control Enter, and if you click on this, you see that there is a huge matrix, which the dimension, as you see that, it's going to be, a vector of 27,000, of, a large matrix, which it's going to be the number of rows only for the replicated of the observations that we had. Now, as we have it right now, the yrep for our model, the next thing that we are just going to do is just going to use the Bayes plot. We are going to go there, in the package, check that if we have the Bayes plot. I'm just going to scroll it all the way up there. For the Bayes plot, you see that the package has been installed before, and now I'm just going to use a library command in order to have the package to be ready to be used. You see the tick, which comes, next to the package. And now the thing which I'm just going to do, I'm just going to use this function, which is from the Bayes plot, which is the posterior predictive, check of, of the models which I have, which is going to be for the dense overlay, which you see that it is essentially the thing which it comes from the Bayes plot. And you see that the things which we need there, I'm just going to go to press F1 to check the arguments which is needed for this plot. I'm just going to scroll it down, and you see that for the Bayes dense plot, for the Bayes dense overlay, we have some things which is needed there. The first one is going to be our true values. What is going to be our true values is essentially the woman's height that we had. You see that the y is created here as a value, a vector, of 15 elements, which each element is the woman's height of those 15 women that we started initially with. However, the second thing which I need, it's going to be the y replicated. For the y replicated, it's going to be essentially the y rep that we created and store that, I should say, and mapped it from the stand into, I should say, the R by creating that object as a matrix called the model that we had and just selecting only the y rep from the model. However, before you execute that, because the y rep, it's a huge matrix, you may get into some problems because it's going to be computationally very expensive. And now, then as a result, the thing which I'm just going to do, I'm just going to only select some parts of the model, let's say, and we can see that, for example, if we are looking for, let's say, for example, check for the dimension of the thing that we had, of the y rep, you see that the dimension is incredibly high. The number of the rows, I should say, for each row is 18,000, and we have 15 features, but each feature represents one of the heights. For example, if I'm just going to do that, for example, I'm just going to, before I just go ahead, I'm just going to create this object here. For example, I'm just going to go ahead with the head of the y rep and only show that, I should say, only, let's say, 1, 2, 3 elements, and all, I should say, you see that, for example, it's gonna show that, for example, for each woman, you see that, for example, y rep 1, it represents the height of the first woman, which is 58.20, which you see that for the first woman we had 58 inches. For the second woman, which is shown by the y rep 2, shows that the height of the second woman is 58.9. We had 59 for the second woman in the vector which is shown here. And also for the woman number 15, you see that for each rows, for the second row we got this number for the first woman. For the third row we had this number for the first woman. And we repeated that for, I should say, for as the dimension which it shows for 18,000 times to get the data, and at the end we are just going to average those heights for each woman to get the estimates which the Monte Carlo algorithm is going to infer for that woman. Then you see that because it's going to be very expensive, I should say very expensive, I'm just going to select for all these 15 women, but instead for the number of the rows, I'm not going to just get it for 18,000. I'm just going to go ahead with, I should say, with the, let's say, for example, 100 of them. I'm just going to execute the line and see the plot which is going to be generated to see that how much the model that we created is going to be close to the one which we have. Now, you see that the model which is replicated is way better than the model that we created on the previous module where we had, I should say, the parameter which it was modeled as a linear model. Now, with the quadratic model, we see that the replicated data, which is essentially the brighter blue, is essentially much way closer to the real data sets that we initially trained our model with, which is going to be at the blue, which is more darker. You see that the replicated ones, in a very improved way, it's mimicking the behavior and the pattern with the real data and the real observation produced, I should say, to create the model that we just trained our data with. And you see that. Then as a result, you see that with fitting the model as a quadratic one, we got a substantial improvements in the way that the model can replicate its own original data sets that it got trained with. And now, the good thing is that we just learned how to do this by using the probabilistic language in a stand. Then as a result, got some kind of, you brushed your skills in a way that you're able to create a model with the memory by adding a block which is called generated quantities, and in order to replicate the data. And then you can visualize it by using the Bayes plot package, which is a good way to visualize the Bayes estimates and the Bayes inferences that you have for your models. Okay. By doing that, essentially, we are just coming to a close for this module. But the next ones, we are just going to go on and introduce some more advanced techniques for, I should say, the Bayesian and especially stand programming, which is a kind of a probabilistic programming language that it also enables you to make some kind of statistical inference. Then I can't wait to start the next module then. See you until then.